continuing with polynomials and functions. Okay, our I can statements, they've changed just slightly. Okay, I can write a polynomial in proper form from highest exponent to lowest exponent. I can identify the degree of the polynomial. Well, the highest exponent is the degree when you have a one variable. I can identify the leading coefficient of the polynomial. Of course, when we put our polynomial in proper form by the degree, the exponent highest to lowest, the leading coefficient is the number out front. And remember, keep the sign with the number. Also, a radical stays with the number. The square root of 7 is completely and totally different than 7. I can identify odd and even functions from a graph. And remember, we're looking at the end behavior. If both of them go the same direction, does not matter which direction. If both ends go the same direction, we have an even function. If the ends go in separate directions, you have an odd function. Each time, every time, all the time. I can identify the leading coefficient of a polynomial graph is either positive or negative. You have an even function, both the ends are going up, then you have a positive leading coefficient. An even function, both the ends going down, you have a negative leading coefficient. An odd function, if the right side is going up and the left side is going down, you have a positive leading coefficient. Okay, the ends are going in separate directions. Now, if you have a negative leading coefficient, then the left side is going up and the right side is going down. Okay, that will happen each time, every time, all the time with an odd function with a negative leading coefficient. Describing the end behaviors, we describe that using arrow notation. You'll say the function goes to either infinity or negative infinity as our x goes to infinity or negative infinity. Our I will statements, we will still, and we can, but we will still continue to identify a polynomial. Today specifically, we are evaluating functions. Okay, we are evaluating functions. Real quick, we're going to do a recap on the end behavior. And so many of us get hooked up on reading the coordinate grid. I do not care at all where the graph is on the coordinate grid. If I have a coordinate grid right here, there's my coordinate grid, and then I have some graph. Again, it doesn't matter what type of graph, okay? It can go up here, okay? And then these continue both in directions. Again, I don't care where that is. I don't even care that I have a coordinate grid. I am literally, I was gonna try to reproduce it, I can't. There we go, okay? My end's the graph. I'm just looking at the ends. Both of these ends are in the same direction. So this is an even function. I don't know if it's to the 4th, to the 6th, to the 8th, don't care. I have an even function at the moment. Since both of them are going up, up is a positive direction, I have a positive leading coefficient, and I'm just abbreviating just for demonstration. We would actually write it all out. A positive leading coefficient. Now, if I'm going to describe the end behavior, just look at the ends, okay? My output is going up, 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 up. My output is my function value, and we read left to right. My output is my function value. My function value is continually going up, 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 up. I'm continually going to infinity. Now, in order to continue up, my input must continue left. Okay, so my input is going left, which is a negative direction, and my output is going in a positive direction. So from the left, my output is going positive as my input is going to negative infinity. That doesn't look really good. Make that as x goes to negative infinity, because like I said, I'm continuing left, I'm continuing in a negative direction, and as I continue negative, my function is going in a positive direction. So now if I look at the right, again, I'm still going up, 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 up. My function value is still going to infinity. But my input value, as my input, my x values, go right, and right indicates a positive infinity. Again, we're only concerned with the ends of the graph. I don't care where it lies on the coordinate grid. Now, just real quick, I'll do another one. Okay, I'm going to do an odd function. We know that a cubic function looks like an elongated S, okay? I purposely, and we know this could be a cubic, it could be to the 5th power, doesn't really matter. This is an odd function. My ends are going in separate directions. So I do have an odd function. Now, is my leading coefficient positive or negative? Well, on the left side, I'm going up. On the right side, I'm going down. So that means I have a leading coefficient that is negative. So this would be an odd function with a negative leading coefficient is negative. But again, I just want to talk about the end behavior, just the end behavior. Again, we read left to right. My output is going up, 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 up. My function value is going to infinity. As my input value, again, I'm going left, 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 left. As my input value, left is negative, is going to negative infinity. Okay, now I'm going to read the right-hand side. The right-hand side, I'm not going up, up, up. I'm plummeting down, 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 down. So my function value is going down to negative infinity. As my input value, I'm going to change to black, as my input value is going in a positive, in a right direction, in a positive infinity. Okay, so just a quick little recap on our even and odd functions, our leading coefficients, and our end behavior. And again, you know, we have even functions with negative leading coefficients. We have odd functions with positive leading coefficients. This was just a real quick recap. Okay. Today we are specifically going to talk about evaluating functions. Our function, f of x is the same as y. This is our function. Our function will equal something. So I put these up here because our function, if we actually think about it, our function is f of x, and I might want to put equals f of x, and f of x actually acts like, well, a function is a really good word. It actually acts, if we want to think about it, acts like our software, okay? Now, our input is our x values, f of x, f of h, g of h, whatever. Our input, our variable, okay? So our input is our x, our variable, our values, what they tell us, or maybe what they ask us. So our input is what we put into it, okay? You're putting in it. So software, we use numbers, spreadsheets, things like that. So, you know, our x values is what we input, what we type in. That's our input. And our output values, okay? Our output values, remember f of x is the same as y. Our output values is our result. What do we get? It literally is our f of x value, okay? So, you know, our function is our software. This is, I'm at a loss for words. This is what we want to happen, so to speak. This is how it works. This is the working function, okay? So what I mean by that is we're going to be given functions. This is a function, okay? And we're going to take it nice and slow. We're evaluating functions at specific points, okay? F of x is 3x squared minus 4x plus 1. That is our function. This is what we will use. Now, I've already got some pre-designated values. We want f of 0. What does that mean? That means we want to know what our output will be when we put 0 into that function. Now, I color-coded it. You know I'm all about color-coding. So I'm supposed to put in a 0, and notice, we replaced x with 0, okay? So that's telling us in this function, wherever an x is, we need to put a 0. So what I'm going to do is I'm going to start here, equals 3 times x squared minus 4 times x plus 1. Now, straight up, I'm going to do this without a calculator. I have 0 here. I have 0 here. I left my x's in parentheses. You need to use that particular notation, okay? Now, I'm just going to start evaluating it, okay? Equals 3. 0 squared is still 0. Minus 4 times 0 is still 0. And plus 1. Well, this equals 3 times 0 is 0, okay? 0 minus 0 is still 0, plus 1, 0 plus 1 is 1. So when we put in a 0, we get out a 1. What does that mean? That actually means if we were to graph this 3x squared minus 4x plus 1, we can go to our x value at 0 and we will get our y value of 1, our function value at 1. So I'm going to pause this real quick. I'm going to go to Desmos and I'm going to graph that for you. Okay, so when I have my Desmos graph, it said, and we just did it, we said that when we plug, maybe, there we go. When we plug in a 0, f of 0 is supposed to be 1. When we plug in a 0, we get out 1. Well, let's check that. X is 0, output is 1. 0, 1 is on our graph, okay? And then, now like I said, we are not actually graphing these. What we are doing is I'm just showing you how we could read a graph and why this is something that we use. Now, what I will tell you is you're always welcome to check your work. But again, we don't always have time to graph it and then read the graph. No, we're just going to plug these in. So I call it a plug and chug. I'm putting something in, I'm getting something out. Okay, we have our input to our computer software, then we have our output. This is the same thing. And again, I'm not working with a calculator. I'm just doing this all by head. And again, I'm going to plug in a 0. Now this is me, okay? And you'll see this on my paper. F of 0 equals. Now, x is supposed to be 0. 0 cubed, or 0 to any exponent, is 0. A negative, and anything times 0 is 0. So a negative 2 times 0 is 0. So I get 0 here, 0 here, 0 here, and then I have a positive 7. So I'm telling you right now, when I plug in a 0, I will get out a 7, okay? And and if you want to use your calculator, do it. It could, be a little bit time consuming maybe if we had to plug everything in, but we can. So I get equals a negative 2 times x cubed plus 5 times x squared minus x plus 7. And again, what they tell us, 0, 0, and 0, okay? 0 cubed is 0, okay? 0 cubed is 0. 0 times the negative 2 is still 0. 0 squared is still 0. 0 times 5 is still 0. Okay. Then we have minus 0. And then we have our plus 7. All of this is going to be 0, and we get our 7. When we plug in a 0, we get out a 7. All that means is 0, 7 are our coordinates, and they would be on that graph. If we graphed it, we go over to x, our output is going to be at 0. Okay, if we put in a 0, we get, 7. If we put in a 0, we get out a 7. That means if we go over, or we don't move left or right, but it's going to cross right at 7. Okay, we're going to do the same thing with the 3. And again, I'm going to emphasize, if it is not on your paper, it does not go in your calculator. A negative 2 times x cubed plus 5 times x squared plus 7. Use those parentheses. Use them in your calculator as well. I'm told to put in a 3. I put in a 3. Okay, I'm working this by hand. I have a negative 2. 3 cubed, I know, is 27. Okay, plus 5 times 3 squared, which is 9. And then I have plus 7. Negative 2 times 27 is a negative 54. I'm going to have to do some work over here. Negative 54. Positive 5 times 9 is a positive 45. And then I have plus 7. A negative 54 and a positive 49, negative 54 and a positive 45 is a negative 9. So I get a negative 9 plus 7 more. Negative 9 plus 7 will be a negative 2. In a perfect world, I can work straight down. So this means when I plug in a 3, I'm going to get out a 2. So the x-coordinate is 3, the y-coordinate is 2, output is 2. That graph will cross on the grid at a 3, 2. Okay? That will cross on the grid at f of 4. I have a negative 2 times x cubed. This equals plus 5 times x squared minus x plus 7. Okay? So I'm supposed to plug in a 4. Oh, I forgot my squared here. Sorry about that. Okay? Times 5x squared minus x plus 7. Let's do that one more time. Negative 2x cubed plus 5x squared minus x plus 7. X is supposed to be, they replace, substituted in 4, 4, 4. Wherever there is an x, that's where that number will be. And again, we're still utilizing order of operations. I've got a negative 2 times, I know 4 cubed. 4 times 4 is 16. 16 times 4 is 64. Okay, plus 5 times 4 squared. 4 squared is 16. And then I have my minus, where am I at? Hold on. Minus, there we go, 4. And then I have my plus 7. Okay? So I know that a negative 2 times negative 2 times 64 is a negative 128. A positive 5 times 16 is a positive 80. And then I have a minus 4. The minus 4 stays the same. And then I have my plus 7. Now again, I'm going to utilize order of operations. Negative 128 and a positive 80. What is that? The 48. Negative 48. We're going to check it. 128, 80, that's 8, that's 12, 4, yep, negative 48. So we get, let's see what that, let me go down, no. So this is equal to a negative 48 right here, minus 4 plus 7. I owe somebody $48 and I borrow 4 more, and I'm going to work over here in a perfect world, I can work straight down. I now have a negative 52 plus 7. So I may owe somebody $52, but I pay them $7. This means I still owe them, what, $45? I still owe $45. So when I plug in a positive 4, my graph will spit out a negative 45. And again, I did this all in my head. It doesn't matter. I'm telling you, if you want to utilize, if you aren't quick and you have access to a calculator, then you can absolutely stop right here and plug that in. But keep in mind, if you plug in this wrong, I have no way to see it. Okay? The more works you show, the more leeway you have maybe to argue points on a test or quiz or something like that. Okay? So, fairly easy. You plug in, you get out. Show your work, work vertically. Now we're also going to check, we did F of 2, okay? F of 2, well, what did F of 2 equal? F of 2 equaled 5. That means when we plug in a 2, we should get out a 5. Let's just check our work. And I'm gonna have to move this down. There we go. Down even a little more. There we go. When we plug in a 2, we're all the way up here at 5. And look, it does intersect at 2 and 5. And last but not least, we plugged in F of 1. When we got out, or when we put in a 1, we got out a 0. Okay, F of 1 equals 0. So what this tells us is our graph, when we plug in a 1, we should get out a 0. So I should have 1, 0 on the graph, do I? X is 1, Y is 0, and I do.